Click the bell icon to get latest videos from Ekeeda.
Hi guys, today we will learn the third numerical which is based on the FET amplifier of especially common gate type. So here we go for the findings of AC analysis parameters, voltage gain, input impedance and output impedance along with DC analysis. See guys, circuit diagram is given over here in which 1K is your source resistance, 2K is your drain resistance, plus 10 volt is given as a drain bias voltage, 4 volt which is looking like 4 volt is given towards the gate side, but it is actually given minus 4 volts towards the source side, and gate is neither connected to output nor at the input side, and that is why we can say that this is the example of CG amplifier. Mind well guys, you have to identify in your examination which circuit is given. No one will tell you that this is example of common gate type, common source type, common drain type. You have to identify by just looking at the input side terminal and output side terminal. If it is not connected at the gate side, then it is your common gate amplifier. So let's start with the analysis. This is just a raw circuit diagram. We will say that given value they have given as the value of IDSS is equal to 6 milliampere and the value of VP is equal to minus 4 volts. This is an example of N-channel JFET. Mind well. To find, we have to find the value of voltage gain, input impedance and output impedance. But keep this in mind, we have to start for the DC analysis first. Question arises, why DC analysis if we want to find out voltage gain, input impedance and output impedance, and more than that we know that the formulas of voltage gain, input impedance and output impedance from the table of complete analysis of CGCS and CG amplifier. But in that formulas, GM is the hidden parameter which is not given, right? And for that, to calculate the value of GM, we have to go for DC analysis. See, for voltage gain AV, we require GM. To calculate GM, we require the value of GMO and 1 minus VGS divided by VP, that is nothing but your formula for GM, right? And this is been achieved by calculating the value of VGS and ID. There is no another option. That means to calculate VGS and ID, we have to go for DC analysis, right? So for DC analysis, we will start with opening the capacitors, that is coupling and bypass capacitor. Here there is no question about bypass capacitor. So what we will do, we will open all coupling and bypass capacitors. Okay, we will redraw this circuit. I can say that this is connected to ground and this is minus 4 volt as well, right? There is no harm by taking this kind of configuration. Okay, now we will apply input KVL. If we apply input KVL, then we'll get the relationship between VGS and ID. This is your value of VGS and this is nothing but current flowing through ID. This is nothing but current flowing through 1K, that is nothing but ID. minus VGS minus 1K into ID minus of minus 4 volts is equal to 0. So we'll be getting the value of VGS is equal to 4 minus 1K into ID. Equation number 1. From equation of ID, we will get ID is equal to IDSS 1 minus VGS divided by VP the whole square. Say that this is equation number 2. Put 1 in 2. We do get, what is ID? We'll keep this as it is. What's the value of IDSS? It's nothing but 6 milliampere. What's the value of VGS from equation number 1? That is 4 minus 1K multiplied by ID divided by VP, which is given as minus 4 volts. We'll take this square. 6 milliampere. Here we'll take the LCM. This will be your minus 4 minus 4 plus 1K into ID divided by 16. We will get a quadratic equation from this particular equation. We'll be getting 2.67 kilo into ID is equal to minus 16K into ID plus 1 mega into ID square. So equation will become 1 mega into ID square, 10.67 K into ID plus 64. Now we have got two values of this roots of the quadratic equation. One is ID1, which is 14.14 milliampere, and another is 4.52 milliampere. Mind well guys, this value is well above the value of IDSS, which is not suitable for the characteristics, right? So from the characteristics, ID should be less than IDSS, right? So ID is equal to ID2 is equal to 4.52 milliampere. If I put this value, then VGS is equal to 4 minus 1K multiplied by 4.52 milli. This gives you the value of VGS is minus 0.52 volts. So we have got two values, one is ID and another is VGS, and we want this value of VGS to find out the value of GM, that is transconductance. Transconductance GM is equal to GMO into 1 minus VGS divided by VP. What's the value of GMO? GMO is minus 2 IDSS divided by VP multiplied by 1 minus VGS divided by VP. Now all values are known to us. we will just put all the values and then we'll find the value of GM. Just take a pause for 3 to 4 minutes and calculate all the values of GMO 1 minus VGS upon VP and club together to get the value of GM very quickly, and then come back. So we have got the value of GM, that is transconductance, is equal to 2.61 millimho. Okay, this should be positive. This is because VP is also negative. Negative here will get cancelled and we'll get 2.61 millimho. Now we'll jump towards the AC analysis. In AC analysis, we'll short all the capacitances, coupling capacitances, and then we will proceed further by shorting DC sources as well. Circuit will become, this will be grounded, this is also grounded, this terminal also grounded, here we'll be getting the output, here we'll apply the input. This is of 2K, this is of 1K. We will try to form the AC equivalent model. First of all, JFET is giving plus minus VGS open circuit because IG is equal to 0. This is GM VGS. This resistance small RD. Here one resistance is applied and then connected to ground. One resistance is applied at the drain terminal connected to ground, and there is no resistance but it is directly connected to ground. And here we'll apply the input, here we'll apply the output. This is how we have done the AC equivalent model. Now we will move towards the calculation of voltage gain, input impedance and output impedance. This is what we have to get actually in this numerical. As far as voltage gain is considered, we all know that the value of voltage gain is equal to GM into RD, because small RD is not given in this numerical. So we'll consider this small RD as open circuit. If we take this as open circuit, then we'll get the same value as that of the voltage gain of CS amplifier with bypass capacitor but without negative sign. So voltage gain VO divided by VI is equal to GM into capital RD. What's the value of capital RD? Capital RD is 2K. GM value we already have taken. 2.61 milli is the value of GM and capital RD is 2K. Milli ne K ko maar diya. We will be getting the value of voltage gain as 5.22. So AV is equal to 5.22. Let's move further for the input impedance. What's the value of input impedance? Input impedance is nothing but RS parallel to 1 upon GM, right? So I can easily say with a calculation with Cal-C, RS inverse plus GM, because 1 upon GM ka inverse itself is a GM, and the whole inverse, right? So check with the Cal-C and calculate the value of Ri very easily. Value is coming out to be 277 ohm. and then we will move further for your output impedance. This output impedance is also capital RD parallel to small rd. You can also give the investigation to find out the value of RO. Here the value of RD and the value of capital RD. Here to find out the value of output resistance, that is RO, we do short circuit at the input side. So if Vi is equal to 0, then I can say that this will become grounded and this RD and capital RD will become in parallel combination. But here we do have open circuit. So I can say that only small RD is neglected and capital RD will come into picture. So only capital RD we will take, and directly we will get the value of RO as RD, which is equal to 2k ohm. This is the value of output impedance that we have got. So far we have discussed about DC as well as AC analysis. Without DC analysis we cannot move further to find out all the parameters in AC analysis. So this is how we have performed the numerical number 3, which is based on CG amplifier using FET. Thank you so much for watching this particular video. I hope you like this videos. So if you like it, then like, share and subscribe this particular video and subscribe Ekeeda channel. Thank you very much.